Okay. So this one you have to multiply by twice, left and right. The width is 0.5. The depth is 5 plus 4 plus 4, 9. And then 9 divided by 2. Okay. So this is 9 times 9 times 0.5 plus 168. So it's 208 0.5. Did I get 208? Yep, 208.5. Okay. Then your shear stress, we are given the shear stress at what? The shear stress value, I forgot now. The shear stress value is 3,000. Okay, so 3,000 P over 2, Q is 208.5, I is 2902. See, my short-term memory is so bad. It is 2902. Thickness is twice 0.5. Right? So P is equal to 3,000 multiplied by 2902 multiplied by 2.5 divided by 208.5 divided by 2 is equal to 20. I'm having a weird number, man. 3,000, 3 power 3, 3,000 times by 2902 times by 1 divided by 208.5 divided by 2 is correct. So it's 20. Wait, 3 power 3 times by 2902 divided by 208.5 is 41, or P over 2 is 41.755 times 10 to the power 3. So P is equal to 83.510 times 10 to the power 3 pounds. Okay. So you can see to induce failure, so this is the wooden structure. Okay, that's the wooden structure. Okay. So that's the wooden structure. And then for the fastener is 6.909. So the fastener is going to fail first. So this is the allowable. Okay, that's the allowable load. So P allowable is equal to 6.909 times 10 to the power 3 pounds based on shear failure of the structure and the joints of fastener. Okay. So this is this is one of the calculation, okay, that we are looking at longitudinal shear. Okay, we're going to do another example. Yeah, I want to do another example with you guys. One that it seems confusing, but it's not that bad if you apply the rules that I teach you. Okay, so let's go for, before I go on, any questions? Anyone? Excuse me. So no. So we will go for example. I couldn't remember how many examples we are doing today. There's example. So we go for example number 5. Okay. Right. So this is the structure that we have. Okay, so I've sketched it out for you guys earlier. Excuse me. So the beam is made of 4 boards nailed together. If the nail can support a shear force of 100 pounds, okay, so the resistance force per nail is 100 pounds. Okay. Now, given that V, the shear force, is equal to 700 pounds, right? We have to find the spacing S and S prime. Okay. Okay. So now I'm going to draw. So this is our X, Y, Z. Okay. So I'm going to before I go on, okay, I will declare that the second moment of area. I'm not going to find this. Okay, I just going to write this out. It's equal to 337.43 inches to the power 4, and the Y bar, okay, is equal to 3.3548. The centroid, okay, inches from the top. Okay. So we know failure will occur, okay, at over here where I'm shading in red, or the other side, or the center part, right? That's where failure will occur. The center part is easy. This beam is easy, okay. The failure on the left and right, that's where a lot of students get confused. What do I mean by that? Okay, so if I'm going to draw the beam now, okay, we're going to draw the beam now. So this is my Y, Z, rotation X, right? So the first thing I recommend you is to construct your shear flow. Okay. So we have learned shear flow already. We start constructing shear flow. So this is our Q. It will come in from here. Right? There you go. So if now we're going to focus on the S prime or S. You find S, which is the spacing of the horizontal nails, right? So for the horizontal nail, right, the failure will occur here or here. But remember, this structure has, you have one terminal here, you have another terminal here, and you have a terminal to end, right? So to find the spacing of the horizontal nail, you only need to consider this area, or the area that I'm going to shade in blue, or not N. Why? Because the shear flow on the left hand side is not affecting the shear flow on the right hand side, right? So for this case, big Q, or before we go into, yeah, we have to calculate big Q. So the formula we're going to apply is Q is equal to VQ over I, right? Applying the rules, we know V and we know I. Q we don't know. So Q is equal, so the area, the cross, so the width is 1. The depth is 3. The Y bar is given at 3.3548 minus by 3 divided by 2. And you only consider one side, right? Because the Q on the left-hand side and the Q on the right-hand side are independent. You don't take both, okay? Take both, you can confuse yourself. So this will be equal to 3.3548 minus by 1.5 times 3 times 1. So it's equal to 5.5644. So this is in inches cube. So Q is equal to, so V is equal to, V is what? 700 multiplied by Q, 5.5644 divided by the second moment of area, which is 337.43. So this is equal to 700 times by 5.5644 divided by 337.43 is equal to 11.543. I'm going to do it again. 700 times by 5.5644 divided by 337.43 is equal to 1. Yep. Okay, so when that's the case, we're going to find Q is equal to 100 divided by S, and this is equal to 1.543. So this is in Newton per meter. So S is equal to 100 divided by, it's equal to 8.663 inches. Okay, and this is spacing for the horizontal nail. Okay, so we have found the horizontal. Next, we are going to find spacing for the what? For the vertical nail. Okay, so spacing for the vertical nail is going in this way, right? And as mentioned before, we know that the failure will occur down here. When that's the case, you have to consider all the what? You have to consider everything now. Everything at the top, right? So whatever from terminal 1, terminal 2, coming to the center, left and right, you have to consider everything. Okay. So next we're going to calculate. Let me copy this so you can see the diagram better. So now we're going to calculate the spacing of the vertical nail. So we know that Q is going to be twice the small one, right? 5.5644, 5.5644. 5.5644 plus, okay, I forgot, let me get this picture. Sorry guys, copy. I'm going to paste here. You can see better. I can see better also. Plus by the width is 10. The depth is 1. And then the Y bar, I remember we had a Y bar 3.3548 minus by 1/2. Okay. So the 2 over here corresponds to this area over here, correspond to this area. And this term over here is considered this one. Okay. So this will be equal to 3.3548 minus 0.5 times 10 times 1 plus by 2 times 5.5644. I got 39.6768 inches cubed. Okay, so the same thing, you calculate Q is equal to 700 multiplied by 39.6768, then divide by I. Short-term memory is really bad. 337.43. So this is 709.6768 divided by 337.43. So it's 82.30 or 310. Okay. So as Q is equal to 100 divided by S, and this is 82.310 Newton per meter. So S is 100 divided by 82.310 is equal to 1.215 inches. Okay, so this is the spacing of the nail. Okay, right. So I'm going to stop over here. Right, you all understand what do I mean by failure analysis now. Okay, and how to calculate the spacing of the nail. So we are a bit early. Okay, so I'm going to stop now. Anyone has question, and again, quiz will be it will be moved, okay, to the what was the date? October the 15th. Okay, is it October the 15th? No, October the 22nd. Sorry. Okay, so that's all I have now. If that's the case,